today let's set up a VVT system in JCI. So there's a couple different ways to do this. Let's just go over what a VVT system is. It's a variable volume, variable temperature system, right? So basically you're a rooftop unit that's serving a few zones, and the zones are going to have some zone dampers that open and close, and they're going to take the temperature of the room to control the unit, basically. So you could do this a couple different ways in JCI. You can use just one unitary controller up here and just put Blemo actuators as the VAV dampers and put some stats in. Or you can put full VAV controllers in here and then share that information up to the unitary controller. There's no right or wrong way. To me, it's easier to do the VAVs, but today I'll just show you how to do it all on the unitary controller. So we're going to come over here to CCT, and then we'll start a new program here. Let's call it VVT. And then I'm going to choose air handler, mixed air single duct. I'll make some assumptions on the rooftop. Let's just go with a single speed right now. Because we're not really controlling duct static. We're just going to control a bypass damper based on the open enclosures of the zone dampers. So we'll just write that programming in. We'll just assume it has economizer and then choose all the wonderful economizer settings here. Then we're going to do zone control for the temperature strategy. I'm going to reset it based on stage cooling and heating. So we'll work on that here. And we'll have, let's just say common set point adjust on our stats. No preheat. We're in Texas. We don't really have preheat. Stage cooling, let's give it 2 stages. And reheat, let's just go with stage. Again, this really doesn't matter. It's all going to be the same. You choose whatever system you have there. Next, I'm going to do outdoor air temperature. We got a mixed air. We got a discharge air. We'll do a return air. Again, just check what you have there. That's all. Now, we got to keep an eye on the system capacity down here, but in order to get a true system capacity, we got to make sure we have a controller selected. So we're going to come over to define hardware and see there's no controller selected here. So we're going to choose the 9090 MSTP variety. There we go. So now we have that. So now our system capacity is 32. So we know what we can kind of do with it. First off, we're going to need zone temp sensors. We'll go by whatever this was. This was 4 zones, 1, 2, 3, 4. So we'll just do 4 zones. So we'll add in our other 3 temp sensors. To do that, we'll go define hardware, SA bus devices, add device. I'm going to scroll to the bottom because I know I'm going to have NS8000s. And I'm going to do zone temp set point. And I'm going to do a 1 here and add another. Actually, I'll do a 2. We'll call that first one a 1. Add device. And then we'll go 3. Add device. And then we'll go 4. Add device. And that gives us our 4 temp sensors there. Close. If we wanted to, we can go and rename this guy. But we're just going to leave it the way it is right now. First off, we need to probably min-max average of these guys. So we'll come over here and do an activity block and call it zone temp. Again, you name it whatever you feel like naming it. We're going to view the logic. And then I'm going to bring in zone temp 1. I'm not going to worry about facets or anything like that. It's just for programming. I'm going to duplicate that. And this is going to be zone temp 2. And then duplicate this. This is going to be zone temp 3. And zone temp 4. I'm also going to do this for the set points. So I'm going to duplicate all this. I'll do it all in the same logic block. It's not that big of a deal. I'll just put SP after this. For set point, all right, let's throw in some statistical things here. I'm sure we want to average. Let's go with a max. Let's go with a min. Set these guys up here because we're going to want 2 more. I'm not clicking edit, I'm clicking IO modifications. That's how you add more inputs to this guy. You click edit, you're not going to get this. That's done. Okay. Duplicate this for our set points. And then I'm going to start just clicking these guys in right here. Whoa, 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 whoa. Look at that. It's driving me nuts. All right. Okay. Don't worry about it. I'm going to hide the lines here in a second, make it look better. Man, I keep screwing that up. I just want to go down the line. It's messing me over. All right, to get rid of all the jungle up garbage, just click the line and hit hide. Any line, come on. There it goes. All right, I'm gonna do the same thing for the set points. Try not to screw this one up so bad. Clear the lines real quick. There we go. Now we need some output blocks here. So we got our average temp. VVT temp. Duplicate. Max temp. Again, you might not need max and average, but I'm gonna go ahead and create it just in case we ever do use it. Points are there. We'll probably just do average on everything just to make it easier. And then outputs for our set points. One. And just make the connections. Not gonna hide these lines since they're only going on one thing. Doesn't really make sense to hide them. They're gonna be crooked. I'm not gonna worry about it. All right, done deal. So now we just have to connect our stuff to it here. Zone 1 temp is just gonna be our regular ZNT. Zone 2 temp is gonna be ZNT2. 4. And 3. Now, see how the order kind of got messed up on there? That's because I did that duplicate of two different things. It acts weird sometimes. Zone 3 set point, really as long as you match them up to the right value, that's all that matters. So 1 set point, 2 set point. And then all you gotta do is make that last connection there, zone 4. And that does it for that block. We'll deal with our outputs here in a second. For the outputs, we just need to go over here and figure out match where they're going. We'll start with the set point because that's probably the easiest one. It just goes to the hardware set point of the zone set point determination. So we go down here, set point, change, connection, and let's just take the average of that block. So set point, we want the set point. Take the average set point. All right, now zone temp's going to have a lot more connections here. Cooling control, change connection. Let's go with average as well. And we'll come back over here. We'll go here, change connection, temp average. And see what I'm doing is I'm going back over here to the zone temp because that's where it was all originally connected to. And then I'm on the connections tab and I'm using these hyperlinks to get to where I'm going. And that temp. As you see, each time I click on it, we're getting lower and lower. And then this will be the final one, average temp. So now when I go back over here, I'm only tied to my zone temp block right here. All right, so that does it for the temperatures. Bring in the dampers and do some damper control programs. So here, zone damper. Oh, look here, we got zone 1 damper, Oh, zone 2 damper? Yes. 2 damper, zone 3 damper, and zone 4 damper. Finish. All right, so now I got my dampers in here. Nice. So now let's think about output control for them. So depending on if the units in heat are cool, dependent is kind of dependent on if you want to open up the damper more or close the damper more to put more air in the room, right? So we kind of got to make our own zone control program off of that. So all right, let's figure this out here. Let's make a hybrid activity. Zone 1 control. All right, so I got zone 1 control. And what we'll do is we'll just duplicate this if we can make it work. View logic, state text. So we know we're not going to want on off. So let's see where we're doing satisfied right here. This is going to tell us if we're in heating or cooling mode. And to verify that, we'll want to go T control right here. Okay, so econ heating. T control is here. Okay. We're going to go off this one. So first I need to figure out what output units this is. This is FC ZNC states. So that's what I need this to be. Logic, click, details. FC ZNC states. Okay. There we go. So now I need an input enum that matches this. All right, so now this mode is going to tell us what state we're actually in. So let's see, we need floats. We know we're going to need a temp. And I'm not going to call it zone 1, zone 2, zone 3 because I'm going to reuse this over and over again. So I don't know which zone I'm going to use it for. I'm going to need a set point. I'm also going to throw one in here for minimum damper. I'm going to go ahead and set that up as a 10 right now. And that's going to help us later on. Okay. So if we're satisfied, what do we, well, hold on. We're going to need output too. We're controlling the damper. I'll drag this other guy over here. Zoom out a little bit. Not that far. There we go. Okay, we're controlling the damper. What do we want the damper to do when the unit is satisfied? So that means that the fan's on, but we're not putting out heat or cool. So I would say let's just open it up to minimum damper when the unit's satisfied. And same thing for temperature unreliable. Okay, so now we just got to deal with heating and cooling. So heating, let's bring in our PID. We'll do our PID preprocessor over here. Move this over. And it's already set up for zone control. So we're going to leave it there. We'll move our PID over here. Down there. So we got our set point here, our process variable here. Then we got our minimum tuning. All this just goes straight across. And we want to expose a point for connection. We want our load limit here exposed. Now our min block can go to our load limit. Hide that line there. And then that goes to our damper. Now we want direct acting to be false. And then really, I just want to duplicate this. Copy for cooling, paste. It's not going to put the connections in for us. It's going to keep the pig connections here. But all we have to do is connect it up. And we do want this direct acting true. Okay. So now, since I screw this up more than all the time, I'm going to actually simulate it. So we'll save it. We'll simulate it. Sometimes, depending on what you're running on your computer, is how fast the simulation goes. I've seen it start up really, really quickly, and I've seen it not start up very quickly. So, good thing is we're putting out a 10 for a damper. And let's say our set point is 68 degrees, and our temp is, oops, right now it's 0. So, 66 degrees. That should be 100, and it is. What if we go to 72 degrees? It should back off. It should back off. There we go. Now, what if we put it into cooling mode? And our temperature is 68. So if we go lower than 68, 66, it should stay at 10. So let's go higher than 68. And there it is, starting to climb. Oh, wait, we should be in cooling here. That's going to show us the true value. Starting to climb. So we know we got the PID going in the right direction. Let's go ahead and set the mode to satisfied. It should just go to 10. And it did. So everything looks good to me. Let me reset my layout. So now we just have to pull in everything. We were going to use this zone sequencing. For our mode, we're going to make this zone 1. So we just have to connect everything to zone 1's. Min damper, I'm not going to do anything with that. I'm not going to connect it anywhere. I'm just going to leave it there. That way we can adjust it inside of CCT without doing a download. You can just go in there and you can adjust it. And then the output block is going to go to zone damper 1. There we go. So now I'm going to export module. And then I'm going to go damper 1. I'm going to do zone damper 2. Get rid of this calf module at the end. Hook everything up to that. Now, for the individual zones, I'm not going after the average. I want to actually grab the actual zone temp of the zone that I want to control. And then finally zone. And there it is. So really, this is all I need. I could do other stuff with it, right? If I had CO2 or humidity that I wanted to control, we can kind of add that stuff in. But for a basic VVT system, we got the zone control over here. We're averaging the temps right now. And we can choose to do high, low, medium, whatever we want to do there. But right now we're just doing the average, and then we're controlling our own zone. Okay, so now we got to control the bypass damper. So if all these close, we have somewhere for the air to go. So let's add a bypass damper. I'm just gonna choose this one. It really doesn't matter. We can go in there and change the name of it, whatever we need to do. But we got that one. Now we need some kind of program for that. So let's go here. Let's go bypass. Bypass damper control. There it is. View the logic. So what I want to bring in here are the damper positions. Because I need to know when all these dampers are closed. I have to have enough airflow for the cooling to work, for the heating to work, and we don't want to blow up any ductwork, right? So we have to figure that out. And I'm just going to make some assumptions here. Okay, so let's just assume that the bypass damper needs to be 100% open when all these are closed, or at 10% at their minimums. I'm going to put in an addition block here and add two more inputs to add all these up. And then I'm going to put in what's called a span block. So we don't want to use a PID block here because a PID block is just going to keep going. It's going to keep going up to 100% even though we're close. So with a span block, be better here. So we got our input, and we want to say our input is our input low is going to be 40. Actually, we want to raise this. We want this to be opposite. So input high is going to be 40. Input low is going to be, let's say, 80% of all four of those is 320. Okay. So when this is at 320% combined, we're going to shut the dampers all the way to 0. And when it's at 40, we're going to be all the way open at 100. Boom, boom. All right. Then, of course, we need to make our connections to our dampers. And we're actually just going to come out of the control block that controls our dampers. And for control. And that's going to go to our bypass. Okay, so now let's simulate it, make sure it works. I'll go ahead and save it. Start simulation. So this will be the last part to the VVT. The first part was how the units on the control cooling heating, right? We just want to take the average. The second part was how to control each individual space, each individual zone. We did that. And this is how to control the bypass damper. Okay, so we see the bypass is open 100% here. Now, as we open up these dampers more, our bypass is going to slowly start to close. See, now we're 85.7. $74.1, $57.1, $32. So we have to hit 320 for this to close off. And it can be in any kind of combination we want, because all we care about is airflow going over the coils. There we go. Now we have enough airflow. Our bypass damper is 100% closed, and it works. And we're connected everywhere. So that's all we needed. So the unit will work the way it is. Of course, we want to go to define hardware. We're over 1 BO, so we will have to add either a 4060 or 9090 expansion. We'll go with 4060 since it's cheaper, right? And we're going to starting index is 4. Boom. So now when I go to point assignments, everything's there. We can move that around if we wanted to. We don't want to right now. We'd set up our network, whatever address we want on the controller, and whatever address we want on the thing. And then take note of these. So make sure your zone sensor 1 is 199. Make sure your zone sensor 2 is 200. 3 is 201, and 2 or 4 is 202. That's very important. You don't want to mess those up. And that's it. We're done. If we wanted N2, we can come in here and create N2 points for it, but it's ready to download. Thanks for watching.